So today we're going to be talking about uniform circular motion. And uniform circular motion is going to be anything for orbits, a car going around and making a turn, something on the end of a string getting flung around like a lasso. And so we're going to be talking about all those different circumstances. So first of all, if you were doing this in class, you would have a device like this where you have a rubber stopper at the top over here, and you have this tube, which I've used some pens that I cut the either end off of, and there's a string that connects the rubber stopper through the pen down to these washers down here. And so here I have what my setup looks like. I've got some washers attached with a paper clip to the string. The string goes through this pen and then is tied onto a rubber stopper. And here's a short video clip. Uniform circular motion is the motion of an object traveling at a constant speed on a circular path. So the velocity, the direction keeps changing, but it's going in a circle. And what we can derive is that acceleration to go in a circle is equal to v squared over r. So sometimes I call this acceleration to go in a circle, or you can call it centripetal acceleration. Now, centripetal acceleration is the acceleration to go in a circle. There is no such thing as centripetal force. Centripetal force does not exist. Centripetal force is instead a force that causes something to go in a circle. But it's not a magic kind of force. It could be a tension in a rope. It could be friction from the ground. It could be any number of things, but there's no specifically centripetal force. So we need to identify what the force is that causes something to go in a circle. And that's the force that's causing it to go in a circle, not this magical centripetal force. So the first thing that we need to talk about is velocity and rotations per minute. So when we're talking about velocity, remember that velocity is equal to your change in position over your change in time. And the distance to go around a circle is circumference. And the equation for circumference is 2 pi r or pi d. So if you are given the radius of your circle or the diameter of your circle, you can determine how far something goes as it goes once around in a circle. So the problem I want you to pause this video and do is, what is the velocity of the airplane if it takes 1.2 seconds to go around the circle of radius 3 meters? Pause this, do it, and then resume. All right, so let's do this. So if I'm talking about the velocity of this, my velocity is equal to the distance divided by my time. And in this case, the distance for this to go around once around this circle is the circumference. And I'm given a radius of 3 meters. So I'm going to use 2 pi r. So I'm going to do 2 pi times my radius, which is the circumference, divided by the amount of time that it takes to go around. So 2 pi times my radius, which is 3 meters, divided by the time, which is 1.2 seconds. And when I throw that into a calculator, I get 15.7 meters per second. All right, so let's do the next one. Now I want to talk about rotations per minute. So a record player rotates at 45 RPMs, or rotations per minute. Vinyl records have a diameter of about 0.30 meters, or 1 foot. We're going to stick to the meters because we're in physics. If there is an ant sitting on the edge of the record, what distance will he go every minute? Okay, so I'm trying to find distance. Well, if I know he goes around the record 45 times, if I know once around, so find how far he goes for once around the circle, and then I can multiply it by 45 to get his total distance for every minute. So the distance to go around once is my circumference. And if I take my circumference and multiply it times how many times I go around, then I would have the total distance he traveled. I'm given a diameter of 0.3, so I'm going to use pi d, and I'm going to multiply that times 45 rotations. So the distance I traveled will be 42.4 meters. A record player rotates at 45 rotations per minute, and vinyl records have a diameter of about 0.3 meters. Now I want to know, if there is an ant sitting on the edge of the record, what is the ant's velocity? Pause this, do it, and then resume. All right, so to find velocity, we need to remember first that velocity is equal to your change in position divided by your change in time. And your change in position is how far it went. So what I want to do is I'm going to use how far he went in 1 minute, and then I can divide it by 1 minute of time. So I just figured out how far he went. He just went 42.39 or 42.4 meters. And it took him 60 seconds to go that far. Then I get a velocity of 0.71 meters per second. So motion on a flat curve. When you have a car go around a curve, it's the friction that causes it to go and be able to make the curve. If you've ever noticed, a car driving on a wet road has a much harder time going the same speed around a curve. In fact, if you go too fast, you will not be able to make a sharp curve. That's because the frictional force is not big enough to pull you in that circle. So this says, on a flat level curve, the friction between the tires and the road supplies the force needed for the car to travel in a circle. If the tires are worn or the road is wet or icy, the coefficient of friction is much less. Without friction, the car will not be able to move in a circle, and it will keep going in a straight line and therefore off the road. Okay. So let's look at an example. A car is traveling at 5 meters per second around a flat curved road in a circular path with a radius of 10 meters. Draw a bird's eye view force diagram to represent all the forces the girl feels as the car rounds the corner. Assume the car is making a left-hand turn from the perspective of the young girl. All right, so I'm going to draw my girl, and a bird's eye view is as if I'm looking straight down at this car. So here is my car, here are the headlights. Here's the driver, okay? And so let's say your girl is in the back seat of the car, and we're about to make a left-hand turn. So from this perspective, my gravitational force goes straight down into the ground. Normal force coming straight up out of the ground. So I'll draw that. It comes straight up. So the only force left to draw in this case is my frictional force, which is going to be to the left. Because if you think back to those examples where you had something flying around in a circle, and there's a string pulling from that object to the center of the circle, regardless of where the object was, here or here, the string pulls it towards the center of the circle. And so in fact, for every single example where you're having an object go in a circle, your net force needs to be towards the center of your circle. So if I'm making a left-hand turn, then it would be like my circle is here. And so my force needs to go towards the center of my circle. Then it asks, what acceleration are the passengers experiencing? So I'm going to look at this equation here for acceleration. So the acceleration to go in a circle, or my centripetal acceleration, is v squared over r. And I'm going to use capital R's because my lowercase r and my v looks really similar. So the velocity that we're traveling at is 5 meters per second, and the radius is 10 meters. So velocity is 5 meters per second, and I have 10 meters. And I'm going to warn you, be careful that this velocity needs to be squared. So I'll get 25 divided by 10, which is 2.5 meters per second squared. So that is part 2. All right, so if a young girl in the car above has a mass of 25 kilograms, what force will she experience as she goes around the corner due to centripetal acceleration? Well, if we take a look at our net force equations, we have the sum of our forces is equal to only our frictional force, that's the only force in that direction, and that'll be equal to ma. And in this case, our acceleration is the acceleration because she's going in a circle. So I'm going to use centripetal acceleration, or the acceleration to go in a circle. And so I get my frictional force is equal to her mass, which is 25, times the acceleration to go in a circle, which I just figured out. So that's 2.5. And I get 62.5. And last but not least, it says, what is the minimum coefficient of friction required? So what I can do is I'm going to remember that frictional force, I know, is 62.5. And the equation for frictional force is my normal force times the coefficient of friction. And in this case, the only forces acting on her are the frictional force that's going to push her to the side, and then she's going to feel a normal force coming up and a gravitational force pulling her down. So when I do the sum of my forces in the y direction, I just have my normal and my gravitational force, and she's not accelerating up and down, so this will be equal to 0, and therefore my normal force will be equal to my gravitational force. And we remember that gravitational force is equal to mg. So therefore my normal force is also m times g. So I'm going to plug that in over here. So my normal force is m times g times the coefficient of friction is 62.5. I'm going to plug in my mass of 25, and g is 9.8. And I get 245 times my coefficient of friction is equal to 62.5. And I will divide both sides by 245. And I get an answer of 0.255 is my coefficient of friction.